Okay, so my name is Cecilia, and I'm going to be going over image acquisition, which was module 2. Ooh. All right, and for my introduction, I'm going to be explaining the difference between computed radiography and digital radiography, which is CR and DR. And then I'm going to discuss what they are, and then with digital radiography, I'm going to be explaining direct and indirect capture. And then finally, I'm going to be explaining digital image receptor response. All right, so computed radiography captures and stores images in the imaging plate, and then computed radiography contains a cassette-based phosphor, which is a storage plate, so it's known as PSP, a storage phosphor screen, which is SPS, and a CR reader. And then with digital radiography, it's used for all types of digital use in radiology. And there's direct and indirect capture. So one of the main differences between computed radiography and digital radiography is that computed radiography contains a cassette and digital radiography doesn't. Cassettes use screens that capture the image and processes it into a digital format. Digital radiography uses direct and indirect capture, which is charged and then processed into a digital image. This is digital imaging. So on the right side, it shows direct and indirect capture. One of the main differences between them is the scintillator, which only indirect has and direct doesn't. So direct capture is hardwired to the image processing system, which means the technologist doesn't have to place the IR into the reader like you do in computed radiography. And then indirect capture is X-ray energy that is converted to light by a scintillator. This is computed radiography. So on the left side, there's an image of what the machine looks like on the inside. And then on the right side, it shows what it looks like outside of the inside of the machine. So what it looks like when we see it in a clinical setting. So when you insert the cassette, the plate is read by the scanning of the laser beam, which is shown on the left side. And then this is where the light is emitted and directed towards the photocathode layer. And from there, light signal is emitted and measured. It's measured and recorded to create an image that we can see on the screen, like we see on the right side, where we see an ankle on the screen. Parts of computed radiography. Computed radiography is made up of many parts. The cassette, which is the phosphor storage plates, PSP, the imaging plate, which is an image receptor, and the CR reader, which turns latent images into visible images. So first, the PSPs receive the latent image, which is an image you know is there, but you cannot see. The image then scans the phosphor plate. The image reader then scans the phosphor plate with the laser, which causes the PSPs to return to their original state. Light is then emitted, which is measured and recorded to create the manifest image, which is a visible image. and then it all resets with the bright light on the imaging plate. Direct capture digital radiography. Direct capture is when the X-ray energy is converted into an electrical charge. Direct capture does not contain a scintillator. Instead, when the X-ray beam strikes the TFT, it is converted into an electric charge by interacting with the amorphous selenium. The amorphous selenium captures and couples X-ray energy. Then the electrical charges are converted and are collected by a storage capacitor, which is then sent off and forms a digital image. And finally, digital image receptor response. That is how the image receptor responds to radiation. So the more radiation, the more you are exposing, causing the image receptor to respond. The image receptor will respond to low and high levels, making it more responsive to a range of techniques compared to film. Then on the right side, it shows a graph. The red is the film, and the black line going across is the digital image receptor response compared to the film. And then you can see how it's a linear response compared to the film, which means the more radiation, the more exposure you're going to get. So in conclusion, computed radiography captures and stores images on an imaging plate. Digital radiography contains two forms of image acquisition known as direct and indirect capture. Indirect capture is when the X-ray energy is converted to light by a scintillator, and direct capture is hardwired to the image processing system, which means it doesn't need a scintillator. And then finally, the digital image receptor response is how the image receptor responds to the radiation. And with that, we compared film and digital. And these are my references.